I'm Nicola Moses, technical marketing manager at Microcrystal. So we have today at Embedded, we introduce our brand new real-time clock module, which is in C8 package, the very tiny one over here, just 2 by 1.2 millimeters. So that's the smallest on the market today. So we are part of the Swatch Group Electronic Systems division, where we combine the knowledge and the strengths of all our assets in terms.
Is there a microcontroller in this small one?
It's a dedicated ASIC. That's not a microcontroller. It's a dedicated CMOS chip, which is managing the register for the time counting. And it's combining a very tiny crystal on top of this dedicated IC.
So your company is part of the Swatch Group?
Absolutely.
So you've been doing stuff for watches also?
Exactly. So company has been created in 1978. The demanding for the quartz crystal for the watch industry, and we are part of the Swatch Group Electronic System division with Renata, which is providing batteries as well for the watches initially, and EM microelectronic.
So here I see new RV-3028-C8. What is this about?
Exactly. So that's very low power device with just 70 nanoamp, able to keep the time and putting the rest of the system in the very low power mode. So
keep the time. What's the potential applications in the embedded world?
So typically these kind of devices are very useful in embedded design to really manage the activity of the system. So you can really schedule operation and put your system in very low power mode between the operation.
And what are these other chips? You're storing a lot of other chips here.
Yeah, so we are a manufacturer of crystals. So you can see at the center a wafer of very tiny crystals. So we are assembled crystals in ceramic packages, but we combine exactly these ones. Very tiny package, ceramic ones, and we combine these crystals either with an oscillator circuitry or with a real-time clock module circuitry.
So, how big is the role for your company in the industry? Are there many people working with you?
So, we are a company located in Grenchen in Switzerland. So we are roughly 100 people working over there, with another factory in Thailand for the final assembly.
And are you, for example, planning of doing stuff like microcontrollers in also very small packages?
I mean, the dedicated ICs is done by EM Microelectronic, which is a sister company within the Swatch Group. Yeah.
So here at the booth, you basically have all the partners a little bit doing different things in the industry.
Yes, absolutely. So we have our partner from Renata, dealing with batteries.
All right. So this is a whole different topics to check out.
Yes.
And here you're talking about more about your...
Yes, so that's our short form catalog. So including a list of our tuning forge crystals, megahertz crystals, of course our real-time clock module, which is really our flagship product. We have also temperature sensor, kilohertz oscillator, and even medical implantable products, which are really dedicated to implantable devices.
Where does it go, the medical implemented?
So that's a booming sector at the moment. So it goes even in smart knees implants, where you can combine this with sensors, having timekeeping and some timestamp of the operation of the products, and how a patient with such implants are using, moving, and applying force strength on the knee. So, of course, we are also producing crystals for pacemakers or brain stimulation, nerve stimulation, neurostimulation, as it's called, and many applications in the healthcare segment.
Here's a kind of like an illustration of the crystal.
Yes, that's the different packages that you can have, you can find. So that's typically the one looking like a gold parts are typically some of the parts that are included in some watch.
And you were mentioning temperature, for example. So there are different uses for the ASIC designs.
Yes, I mean, the characteristic of the crystal is that it's dependent. It has a dependency versus temperature. So the idea is to use a temperature sensor to compensate this temperature dependency in order to have an accurate timekeeping. What we have found is that the temperature sensor used in our real-time clock module is so good that we can even use it just as a temperature sensor. You can set alarms when and timestamp to detect when a temperature is reached, if it's below a certain temperature or higher. So this kind of sensor with ultra low power can be used in, let's say, chemical management, pharmaceutical management, the cold chain industry, all these kind of activities. Yeah.
And in the world of AI, I could imagine maybe you want to wake up from very low power from one of these, and then you can trigger a bigger microcontroller to turn in.
That's exactly the point. I mean, all these, that's as we like to call it, that's the smartest way to extend battery life of your system. So you just have this small part active when the rest of the system is in power down mode. So that's really the aim of the real-time clock module.